Alright, now we want to look at quadratic equations, which is going to take a little bit longer than the previous videos, in part because I'm going to prove one thing to you. I can't stand having things sort of handed out that aren't proven. So the first thing is, you might get a quadratic that looks like this. If it already looks like this, you can use that if two things multiplied together equals 0, then one of them equals 0. And if either one of them equals 0, then it does equal 0. So you either have this or this. These are the only two options for this. So in this case, x equals -7. In this case, x equals 3. These are your two solutions. So that's your solution set. That's called the zero factor property, but it's pretty clear, I think. You might also have something where you just straight up take a root. So x squared equals 9, say. If you end up with this, then you say, well, either x is 3 or it's -3. So that's taking the root on both sides. Now, note that if you saw this, if this is what you were given, then x would just be 3, because this is called a principal square root. But what I was given as x squared equals 9, I took that root myself. If you take the root yourself, you have to do a plus or minus, or you lose a solution. So similarly, I might have x minus 4 squared equals 9. And then I would say x minus 4 equals plus or minus 3. So then you have two different things going on. That equals 3, or it equals -3. So you add 4 to both sides. And these are your two solutions. I'm not actually certain. I think you've all had Algebra 2 at this point, so I think you have factored quadratics before. But almost everything in math is just, well, almost everything in calculation-based math is just undoing something else, doing things, undoing things. So factoring is unmultiplying. So if I distribute, then I have x squared plus 3x minus 7x minus 21 equals 0. So this minus 21 was -7 times 3. Just tuck that in your pocket. And then here we have x squared minus 4x. This minus 4 was 3 plus -7. So 3 times -7, 3 plus -7. So when we do that factoring where we go over and make a little tree, which I'll do in a minute, what we're doing is finding the things that got multiplied together. Otherwise, we could have just used the zero factor, but if someone's already multiplied it out for us, we have to kind of find what got multiplied. So we're trying to undo it. So if I'm just given x squared minus 4x minus 21, so if I'm given x squared minus 4x minus 21 is 0, then I come over here and I want to find the two things which were multiplied together to give -21, and which were added together to give that -4. So I think of all the possibilities. So 1 and 21, where either one of them is negative, those are possibilities. 3 and 7. And then I look which of these adds up to -4. And that's how I know it's x plus 3, x minus 7. It's also possible I would have been given something like this, and then I have to move that 21 over first. So you've got to get 0 on one side, because eventually your goal is really to use that zero factor property. So you've got to get 0 on one side. If I just say, hey, two things multiplied together to get 21, well, that could be like anything, practically. any number besides 0 could be multiplied by something to get 21. So it's not very practical, so we've got to get 0 on one side first. So let's say that I have something like this. And I come over here and I say, okay, I need something that multiplies together to give 5. So it's either 1, 5 or negative 1, negative 5. But that makes negative 6 and that makes positive 6, and neither one of those is negative 8. So what do I do? So now there's a technique called completing the square. So remember that if we had something squared equals something, then we could solve. Even if it might be complex, we would have been able to solve because now we know how to take the square root of a negative anyway. Okay, so side note, if I have something squared, then I have that. So I have x squared minus 2bx plus b squared. The point here is that if I'm going to have something squared, it's going to look like this. I should have just made that plus for the sake of this. It doesn't matter, but just to not confuse you later. So the guy next to the x is 2b. So I can see then that b should be negative 4. So what I do is I take half of this value, well, the first thing I do is move the 5. It's not actually the first thing I do, but technically for the algorithm and to keep things kind of clean, you should do it first. So I moved over the 5. Now I'm going to take half of that, negative 8, and square it. So now I've made something that looks like this. Okay, so if negative 8 over 2 is b, then negative 8 is 2b. Right? But I can't go around randomly adding stuff, so I've got to add it over here also. So now I've got x squared minus 8x plus 16 equals minus 5 plus 16. And what I made this is x minus 8 over 2 squared. That's what I built it to be. That's what I was doing by adding that 4 squared. That equals 11. Now I can take the square root on both sides. X minus 4 equals plus or minus square root 11. So either x minus 4 equals root 11 or x minus 4 equals negative root 11. We'll pretend you can see that. So either x equals 4 plus root 11 or it equals 4 minus root 11. So these are my solutions, whatever they are. So again, that could have been, instead of 11, it could have been negative 11, and then I would just have 4 plus root 11 times I, 4 minus root 11 times I. This now brings us to the confusing segment of our program, which you can skip if you want, but if you want to know where the quadratic formula comes from, then you have a right to know. So let's suppose that I started out with ax squared plus bx plus c equals 0. So those are any numbers you want. So the first thing to do is to move the c or divide out the a. Because remember the thing I did before where I was saying, oh, well, it needs to look like x squared plus blah, blah, blah. I had just an x squared. So the a needs to go. But you can do it now or you can do it in the next step. So I'm going to do it in the next step. So I have this. Then I'm going to take out the a. Now, To complete the square, I need half of whatever this is. Half of whatever this is b over 2a. And that's going to equal negative c over a plus. So over here, I have made this be x plus b over 2a squared. And over here, I have negative c over a plus b squared over 4a squared. And I'd probably like this to have a common denominator, which is going to be 4a squared. So I need to multiply by 4a divided by 4a. Well, that's a 2. So I take the square root on both sides. And I'm going to rewrite this as b squared minus 4ac. Plus or minus. I can take the root of this. It would really be plus or minus 2a, but I've kind of dealt with the plus or minus over here. Plus this makes plus the whole deal. Minus that also makes plus the whole deal. Plus minus, minus plus, that just makes minus. So this actually has all of those in there. So x equals negative b over 2a plus or minus. And nicely, this already has the same denominator, so negative b plus or minus. Okay, there should be a c there. Now, this gives us a couple of things. One, it gives us a way to solve crazy quadratics. I can just say x equals negative b, so negative and negative 4, plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is 4 times 22. So those are my two solutions. So that's one thing that it buys us, is this kind of easy way to solve. Be careful though, because this might be written out of order. So let's say that this said 2x minus 4x squared minus 9. Remember that b is always the guy next to x, c is always the guy by himself, and a is always the guy with the x squared. The other thing this gives us though is if I have, say, x squared minus 4x plus 4 equals 0. And let's say the question is, how many real solutions are there? Because adding and subtracting that square root, if the square root is of a negative, then there are 0 real solutions because those are complex in both cases. If it gives 0, then I'm adding and subtracting 0, so I'm getting the same number both times, so there's 1 real solution. If the square root is of a positive number, then I'm adding and subtracting something from the same value, so I'm getting 2 different numbers. So this b squared minus 4ac, which is called the determinant, this, if it's negative, gives no real solutions. And if it's positive, it gives 2 real solutions. And if it is 0, then it gives 1 real solution. So I can quickly check just by b squared minus 4 times a times c. In this case, at 0, there's 1 real solution. If I had x squared minus 4x minus 4, b squared minus 4 times a times c, this is 32. So it gives 2 real solutions. If I have this one, then b squared minus 4 times a times c is negative 16. It has 0 real solutions. So that's what you need to know for the moment about quadratics.